Okay, today we're going to look at solving some systems of equations. Now the first is just a straightforward linear system of equations. I'm going to use the method of elimination, or the addition-subtraction method as you may see it referred to. Now looking at this, it's going to be easier to get rid of the y's. I always prefer to add the equations than subtract, less chance of mistakes. Now if I times the top one by 4 and the bottom one by 3, that gives me both 24y in the middle, so I can add them. This will give me 16x plus 24y equals 280. And the second one is 21x minus 24y equals 36. So you notice the top one is plus 24y, the bottom one is minus 24y. That's why we add them, because they're opposite signs. This will give us 37x equals 316. Now if I divide that out, we get x equals approximately 8.54. Once you have the x, we can use that to find the y value. It's always best to sub it back into one of the original equations, doesn't matter which one. In this case, it'll be easier with the first one. And then we try and isolate y, giving me approximately 5.97. Now the second example here is what we call a fractional system of equations. Now this is one of the more difficult ones because the variables are in the denominator, so what we often do is a simple substitution. So we substitute a equals 1 over x and b equals 1 over y, giving us the equations and then from here, we need to get either the a's the same or the b's the same, but I also like to get rid of the fractions first. Now in this case, if I multiply the top one by 4 and the bottom one by 3, this will get rid of the fractions. But this also works out where it will also give us the same b's, so we can actually do both things in one step. So we get 8a minus 3b equals 10. And then the second one, we get a plus 3b equals 24. We're going to add the equations again. This will eliminate the b's, giving us, and dividing, gives us an a of 3.778. Now we can use that a to get b. Let's use the second equation here. Get 3.778 plus 3b equals 24. Isolating b will give 6.741, but we're not done there. That's a and b. The original question asked for x and y. So x is 1 over a, which will be approximately 0.265. Y will be 1 over b, which is approximately 0.148. Now this last example is a nonlinear system. If we were to graph this, y equals 1 over x, which is a reciprocal function, looks something like that. Now the other one is a line, and it'll be something like this. So we're going to be looking for 2 points of interest. Now, there's 2 or 3 ways you can do this, but it's quite easy just to plug 1 over x in for y into the second equation. Now if we multiply both sides by x, we can get, which is just a quadratic, so we can rearrange so it's equal to 0. And then we can use the quadratic mode in our calculator, giving us 2 x values, 1 for each point. We need the y's to go along with them, and to do that, we can just plug them into the original. So we get the point, 4.74, 0.21, and then the other one, giving us us the point 0.26, 3.85. And those will be our 2 points of intersection in this case.